Hi, Amy. How are you doing?
Hi, sir. I'm good, thank you. How are you?
Good, good. So I got your message. You wanted to learn how do we solve mechanics problems where we have a pulley and two masses hanging on it, right? I
Yeah.
did see some of the examples which you are struggling with. I thought in today's lesson we'll actually look into the concepts. And I like to begin from the very beginning, kind of review what we already have learned earlier, so that it can refresh all the formulas. Since now, in this unit 2 of mechanics, you have to use a lot of things which you already learned in unit 1, correct?
Yeah.
Which basically
Yeah.
relating relations between displacement, velocity, acceleration, and time, correct? So with pulleys, the
Yeah.
problem which you shared with me had mass into it and acceleration, and that leads us to the Newton's laws of motion, right? So we will connect
Right. Yeah.
the motion with the cause, which causes the motion and its effect. So that is what this chapter is.
Oh, okay.
You understand?
All
So
right. Yeah.
when
Mhm.
we talk about mechanics, we have two different parts of it. One we say kinematics, the other one is dynamics. So I'll actually talk about kinematics and dynamics today. And with your example, I've actually created some very similar question. And I'll try to explain you how they go hand in hand. And that is very important to understand. And I hope with that, you will be in a position to solve any question from your book. That's the whole idea.
Okay.
So here is
Yeah.
a lesson which can help many students like you to understand the concept of physics. But my angle will be, as you know, more towards the mathematics part of it. How do we model this physical problem as a real life application in mathematics? What kind of assumptions we should be taking, and how should we be answering such questions? Rather than providing you with with a solution of your question, right? As I
Solution.
told
Yeah.
you, you have
I
to
don't want that. Yeah.
you have to
I want to
solve.
understand it. Yeah.
Just understand the concept. Is that clear to you?
Hmm. Yeah.
Okay.
Yeah. Yeah.
So that's
Definitely.
going to be the approach for today's lesson. Let me share with you the screen. Okay. So can you see my screen, Amy, now?
Yes, I can.
Great. So as shown on the screen, we will talk about mechanics. Now, mechanics can be divided into two different parts, as I was saying, kinematics and dynamics. So in kinematics, we are only looking into the motion. Motion means change in position. That is what motion is. Now, one question to you. If the object is at rest, can we say it is in motion?
Well, if it's at rest,
Yeah,
um, the displacement and like the position of it would be zero,
correct. Change in, yeah,
and so
displacement.
it's not.
No, no, it is in motion. It is in motion.
Oh.
The object which is at
Oh.
rest
Okay.
is actually in motion. So when the object is in motion, we are talking about displacement. This displacement could be positive, negative, or even zero. So even when the object is
Oh.
at rest, it is in motion. You remember that part. So it is a very
All
confusing
right.
question.
Okay.
So remember
I
that.
thought at zero it would. Yeah. Okay.
Zero means
Trick
displacement is
question.
zero. It is as if you are walking towards the school, but you stop in between when you meet a friend, but still it is all in motion. Do you see my point?
Oh,
Right.
I
So at that
see.
instance, you are at rest, you will think, but it is a part of your motion. Think like this.
Right.
And when you're
Okay. Yeah.
returning, it is negative. So it is all positive, negative values, including zero. Okay, that's very important. In
Oh.
dynamics,
Yeah. Yeah.
we are actually seeing the cause of motion, right? An object stays in its position because of its inertia
Mhm.
until and unless external force is applied. So that
Right. Yeah.
force changes the state. Even when an object is moving at a constant velocity, until and unless external force is applied, it will not change the velocity. It will stay
Oh.
in its position of constant velocity, right? No acceleration.
Right. Yeah.
When the force is applied, second law comes into play, and it says, well, when the force is applied on this mass, there will be an acceleration will be which will be proportional to the force. And we say this
Oh. Right.
acceleration is
Yeah.
force divided by the mass. That is dynamics.
Hmm.
You understand now? Kinematics
Yeah.
and
Yeah. That's
dynamics
clear.
go hand in hand. We could
I
calculate
didn't
the
know that.
acceleration. Yeah, we could
Yeah, it's
calculate.
so funny
Yeah,
because I've done both these topics, but I didn't realize they both came under mechanics as in this way. I knew
yeah,
they were two different things, but I didn't realize the connection between them. That's
yeah.
what I'm trying to say. So
That
yeah.
is what each and every student should understand when they are doing
Oh,
physics or mathematics of mechanics. Okay.
right. Yeah.
So remember that part. So the most difficult questions are when we mix them up. We talk about the unit two, which is dynamics, and we tell you, well, fine, velocity, acceleration, and displacement. You
Yeah.
have forgotten all those things by this time, right? And so it becomes
That's what.
very
Yeah.
difficult, very difficult. So keeping that in mind, because I deal with students and I know what they forget, and the key is we forget faster than we learn. That is kind of
Oh,
important. And
great.
so we don't really remember anything, right? So my
Oh.
approach is my approach is when I want to teach you a chapter, I like to take a step
Mhm.
back, remind you, and then take two steps
Yeah.
further. Otherwise, there is no point in
I
going
definitely
forward.
need that.
So
Right. Right.
that is what
Because
it
if you
is.
forgot the things before, then how can
How
you
can
move
you move
forward?
forward,
That's
right?
right.
There is no point. So any student like you will definitely get benefited from this particular
Yeah.
video, since I'm going to take you back a step and then move forward, right? That's the approach.
Okay. Yeah.
Can you please read the question on the screen?
Yeah. So two boxes with mass of M1 and M2 are attached at the end of a light inextensible string.
Correct.
The, the string passes over a fixed light pulley, as shown in the figure.
Hmm.
When the masses are released from rest, the string is taut. The mass M1 travels vertically down a distance of 2.5 meters in 1.25 seconds.
Correct.
Find the acceleration if M2 equals 3 kg.
Mhm.
Find the mass of M1 and find the tension in the string.
Correct. So that's your question, which we are going to discuss. Before getting or jumping into the solution, we'll go through the concepts which we learned earlier, right? So that is
Okay.
taking a
Yeah.
step back. And let me also give you some basic concepts about what is mechanics. I will like you to read this screen. I've already discussed all this with you to begin with, right? So can you please read
Mhm.
what I've written here?
Okay. So mechanics is a branch of physics related with the motion of bodies under the action of forces.
Correct.
Kinematics is the part of mechanics that relates the four variables of motion to one another.
Correct. So you remember
So
these
yeah, the
equations?
formulas.
Those four
Susa,
formulas,
yeah,
right? Yes,
yeah.
sure. So these are the part of kinematics. There is no force in this formula. Do you see that? There is no mass in
Yeah.
this formula. So this is simply, we're talking about the motion, the displacement, velocity, acceleration with respect to time, right? So that is
Right.
what it is. And now we'll talk about dynamics, where we are more interested in the external force, which changes the state of equilibrium, right? So that is what it is.
Oh, okay.
Or sometimes bring it to equilibrium. Either way, correct. So can you
Yeah.
please read this?
So dynamics is the part of mechanics that is related with the cause and effect of the motion relating force, mass, momentum, and energy.
Correct. So, and
Oh, okay.
he is Newton's laws of motion, correct? Once again, can you read this question and answer?
Oh, okay. So if a physical body is at rest, will it be considered in motion?
Yes, can
So,
you answer
okay.
this
So
now?
this is what you were saying, where so even if so with displacement, it can either be positive, negative, or even zero.
Correct.
So when something's at rest, that means the displacement is zero, and therefore it is still considered in motion.
Correct. It's a part of a
So
motion.
yes, is
Correct.
the answer.
Now, here are the Newton's law, and how do they relate to the physics of all this? Can you please read all this?
Mm. Okay. So Newton's first law of motion defines inertia.
Inertia. This is very important statement. First law defines inertia. And what is inertia? Here it is. Read it.
A physical body maintains its state at rest of uniform
Rectilinear motion. Straight line.
rectilinear motion.
Rectilinear straight line motion. Yeah.
Oh, right, okay. Unless an external force is applied.
Correct. Newton's second law. Please read that.
Newton's second law of motion relates force and mass with acceleration.
Hmm.
So the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to its mass.
Correct.
The direction of acceleration is in the direction of the net force acting on the object.
Perfect.
So the formula, yeah. A
And also
equals
this formula
the
can be
net
written
force.
F equals to ma, right? F is the net force,
Right,
right?
yeah.
Okay. Newton's third law, please.
It describes the nature of force as a result of a mutual and simultaneous interaction between two different objects.
Correct.
So action is equal and opposite to reaction.
Perfect. So with our thanks to the great Newton, let's begin, right? So it's the
Yes.
Constitution of England, right?
Yeah, for sure.
Correct. Now modeling. So whenever we solve such questions, few more important things is to understand the significance of the terms. When we say light, inextensible string, pulley, and masses, what all this means and how does it relate when we are trying to model this situation into a condition given to us, right? So can you
Right, yeah.
all these modeling assumptions which we had seen earlier also? Yes.
Yeah. So when a flexible cord pulls an object, the cord is said to be under tension, and the force it exerts on the object is the tension Ft.
Correct.
So a cord is inextensible with a negligible mass,
Mhm.
and a flexible cord can only pull and
Correct.
cannot push an object.
Correct.
Oh, okay. So light object. The mass of the object is negligible compared to other masses,
Mhm.
and the force exerted at one end is transmitted undiminished to each adjacent piece of cord along the entire length to the other end.
Great.
So tension is basically the same at both ends of a light string.
Correct.
Okay. Inextensible string. So the string that does not stretch,
Mhm.
and acceleration is the same in objects at both ends of a light string.
Correct. So these are very important things. So when you draw a free body diagram, you now exactly know that the tension is same all along the string. Acceleration
Right.
is also same all along the string, right? That is very
Okay,
important.
yeah.
And what is a smooth light pulley?
It means that pulley has no mass,
Mhm.
and again, the tension is the same on either side of the pulley.
Perfect. Now let's look into the solution itself. So what I've done here is we've taken this question once again, and in
Mhm.
this question we are given that there are two masses m1 and m2. We are also given that mass m, one of these masses m2 is 3 kg. So this mass is 3 kg here, right? And this mass is not known, but we know that the mass m1 travels a vertical distance uh, of 2.5 meters in 1.25 seconds. So we know this mass actually travels when released a distance of 2.5 meters. So this is a vertical distance in time t, which is 1.25 seconds. Is that clear to you?
Seconds. Yeah.
That is clear to you. So can you once again read the question and we will look into the concept of solving this particular question. Yes, Amy.
All right. So two boxes with mass of m1 and m2 are attached at the end of a light inextensible string.
Mhm.
The string passes over a fixed light pulley, as shown in the figure.
Mhm.
When the masses are released from rest, with the string is taut. The mass m1 travels vertically down a distance of 2.5 meters in 1.25 seconds.
Correct.
Find the acceleration and tension if m2 is 3 kg, and then find the mass of m1.
Correct. So, Amy, at this moment, I'd like you to take 2 minutes, write down how you should approach to solve this question, and then we are going to discuss it further. Is that okay? So, we'll just take a break
Okay.
for 2 minutes. Okay. So, write down your solution, then
All
we'll.
right.
Okay.
Okay.
Nupur, you can go now. Actually, my daughter had to leave the house and there was disturbance. So I thought, let them go and then we'll continue. Is that okay?
Okay.
Yeah, yes.
Yeah.
I'll cut this out
That's
from
fine.
our recording. Okay, fine. But
All
we'll
right.
start from where we left. So write down your solution. We'll discuss from your solution.
Okay.
That'll be good.
Oh wait, do I actually have to solve it, or can I just write the method of solving it?
Just write the method. We'll discuss, and I'll write down here.
Okay.
Don't worry. Yeah. No,
Right.
I'm taking a break. Let them go, because then there's a
Okay.
disturbance in the class, right?
Right. Find acceleration and tension. Okay. So is your diagram like accurately drawn?
Yes.
Oh, okay. Go.
What do you think? Why it is not
So,
accurate?
no, I just want to know because I don't know what M1 is, and so
M1 you
if
have to find.
M2 is the lighter one, it will
M,
go up.
M1 is heavier. It is greater than,
Okay.
and because it goes down, and it is to be found. Correct. So, Amy, we'll just
Okay.
continue from here now. They have already left. That's a good thing. And we'll
Okay.
talk about the concept, right? So, let me just. So, Amy, did you work out the method of solving it?
Yes, roughly.
Roughly,
I
okay,
think.
let's discuss. Let's
Yeah.
discuss. What should be our approach to solve this question? Tell me.
Okay. So I kind of, because we just discussed about the assumptions that we can make.
Yeah.
So in the question, I just kind of highlighted the stuff like light inextensible string,
Mhm.
and light pulley,
Mhm.
and from rest. So with the light inextensible, I know that the tension is same throughout the whole system,
Correct. Correct.
at either ends. And then where it says light pulley, I know that the mass of the pulley is basically negligible, so you
Yeah.
don't have to worry about that.
Correct.
And then since I'm seeing like values that include the like SUVAT things, I kind of wrote down the values that are already given in the question.
What are the
So I
values
gave
given?
S equals, yeah, so S equals 2.5 meters.
Yes.
U equals 0 since it says released from rest.
Correct.
And then I put T as 1.25 seconds.
Correct.
And then since the question says find acceleration, the formula that we can find A is S equals UT plus half AT squared.
Perfect.
And I'm just subbing the values.
That is the part of kinematics, correct?
Oh, okay, yeah.
Unit 1.
Yeah.
So from this information given to us, we can actually use this formula and the given values to find acceleration A, correct?
Okay,
So
yeah.
that is the first part. So find the acceleration and tension. So we'll do tension later, right? We'll do tension later.
Okay, yeah.
First, find acceleration, because that tension and the mass takes us to the dynamics part of this question. So first find acceleration, right? So we'll use this
Oh,
formula
okay.
as you're saying. Let's move on. So I have done exactly what you said. So we know we need to find acceleration. The initial velocity is 0 since they are released from rest. And during this time of 1.25 seconds, it travels a distance of 2.5 meters using the formula S
Mhm.
equals to UT plus half AT squared, substituting the values and then isolating A. Use calculator, you find the acceleration as 3.2 meters per second square. Get the idea? So this is our first.
Yeah.
We just calculated. Now, important
Okay.
here is physics part. Significant figures. When you look into all these numbers, we have to be accurate to two significant figures, and therefore I rounded my answer to two significant figures, and acceleration should be written with units as 3.2 meters per second square. Is that clear to you?
Mhm. Wait, if it, because in this case, you know, the time is done to 3 significant figures. Do we have to do it to the maximum, to the lowest significant figure,
Yes,
or?
lowest significant. Yes, because
Oh,
these things are not very
okay.
accurate to third decimal place, so we don't know actually, right? So we have to
Oh,
move
right. Yeah.
significant figures.
Okay. Yeah. Yeah.
Correct. Now let's look into the second part of it. What I thought is I'll make it a general solution. So basically, we have the same situation. We have two mass hanging from a pulley, as shown with a string, which is of negligible weight. So we'll actually solve this question, derive our expression for acceleration and tension. Once we do that general formula, then we can apply that formula to any question as given here, substitute the values and find the answer. Is that good?
Okay. Yeah. 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 Sounds great.
So we'll begin always with a free body diagram. So here, can you please read the question once again, and then we'll talk about the diagram.
Yeah. So two boxes with mass of M1 and M2 are attached at the end of a light inextensible string. The string passes over a fixed light pulley as shown in the figure. Find general expressions for acceleration of each box and the tension in the cord.
Correct. So now, here is what is called a free body diagram or a force diagram. So look at these two portions individually. Do you know why?
Okay.
In this particular case, we look at them individually, not as a, earlier we had done some masses on, like a train, right? They're
Table. Yeah.
horizontally placed, right? When they are
Yeah.
attached to the string, we could treat that as one system. But here, we can't
Right.
treat these two as one system. We have to treat them as two different systems. Can you tell me why it is so?
Um. Oh, because the masses are different. I don't know. I don't know.
Because the direction of movement is different. If there are,
Oh,
that is why.
one's going down, one's going up.
That is
Right.
why we have to treat them as two different systems. And so that is kind of important to understand, right? We don't realize it while
Yeah.
working most of the time, but this is important. So if
Yeah. Yeah.
everything is going in the same direction, you could make the whole block as one mass. You could do that, but not here.
Oh, that makes sense. Yeah. That's
Okay.
why you were talking about with the train one and all the carriages. You can
Yes.
treat it as one system because even all the carriages are moving in one direction
Same
along
direction.
with the engine or whatever's pulling it. Yeah.
So when we talk about pulleys, different directions are there. So it makes those many different systems. Okay. So since M1 is moving downwards, clearly M1 is greater than M2. Clear? So based
Yeah.
on that, we say it is moving at the same acceleration A. Now, tension is the force which is uh, resisting the movement as such. And from the first system of M1, we can write down our equation M1G minus the tension is M1A. Do you see that?
Mhm.
Net force
Yeah.
which acts at this point is the difference of force downward, which is the weight, M1G, and the upward, which is the tension. So that is our net force. Do you see that? So basically, we are writing here that the F net, sum of all the forces, F net, is equal to MA, change in
Yeah.
this acceleration is, right? M1A. So that is what our second law of Newton is. So mass is M1, acceleration is A. We get our equation number 1. Now, looking into the second system, it moves upwards. Since it is moving upward, tension is higher. So Ft minus
Yeah.
M2g is causing the same acceleration A on the mass M2. And therefore, we get the second equation, which is Ft minus M2g equals to M2A. Is that clear to you?
Yeah. Yeah.
So now we have two equations and only two variables which we need to find. Unknowns are A and Ft, the tension and the acceleration. You can easily eliminate and do. So if I add them up, Ft cancel, we can find what acceleration is. Once you know A,
Hmm.
you can substitute the value of A and find the tension. So simple as that, correct? You understood the
Yeah.
approach? Let's
Yeah. That's
move
clear.
forward. Clear, right? Let's move forward. So here, what I've done here is we have realized that, can you please read this system of equations which we have
Yeah.
created?
So boxes are moving in different directions, and so we will consider two systems.
Correct,
They will have the same acceleration and tension because of flexible, inextensible string and the light pulley.
correct. And the two equations which
Assumptions
we
we
wrote
make.
are these, right?
Yeah.
Right. So if you add these two equations, as I was saying, Ft and Ft will cancel away.
Cancel.
We get M1G minus M2G equals to M1A plus M2A. Take G common on the left side, A common on the right side, divide and isolate A to get the general formula. So the general formula for acceleration is difference of masses divided by sum of masses times the gravity. Easy,
Times G. All right.
easy to remember.
Yeah. Yeah.
Difference of masses divided by mass of sum of masses times G, right? Do you see that?
Mm.
G is the external force which is being actually applied on this system where the two
Right.
masses are hanging. And that is causing the acceleration, correct? And you get your general formula. Now, once you
Yeah.
do it,
Yeah.
just make a note of this particular important formula. Just as you have 5 formulas from kinematics, this becomes one of your
Yeah.
important formulas in such a situation for pulleys.
All right.
Hmm.
Just got it.
I can actually substitute this value of A from here into this particular place and find what F2 ft is, tension is, right? Rearranging and calculating. M2 M2 is common. So what you see basically is that A
Oh.
plus G, right? M2 common, right? You get your
Mm-hmm.
value of ft, correct? You see that?
Mm. Yeah, yeah.
So what
You
is that?
substituted that A back
A
in,
there, A
yeah,
is
to
on the
find
other side.
tension.
So basically it is A times, uh, sorry, it is M2 times, not A. M2 is common, right? M2 times A plus G. Is that clear to you? If I bring this to the right side,
Oh, yeah, yeah.
so M2 times A plus
Yeah, yeah.
is your answer. A is known to you. Calculate the value of A, substitute, and find MT.
All right. Yeah.
Simple, simple. Multiply with M2. You get your answer for tension. Do you see
Oh,
that part?
yeah,
Very,
because
very
M2
simple.
is common. Yeah.
You
I
see
like
that?
how you did that. Yeah.
It's so that is what it is. So what I've done here is actually derived the whole thing, which is much lengthier and cumbersome than it was looking earlier. Earlier, you calculate
Right.
the value, substitute, get your answer. So basically, we found the value of A. I substituted the value of A in this particular expression after bringing M2G on the right hand side. So clearly,
Mhm.
when you substitute A also has the term G in it, right? So you can take M2G.
Right. Yeah.
We have M1 minus M2 over M1 plus M2 plus 1. So I have solved this here, right? M1 and taking
Hmm.
denominator, we come up with a very simple formula of tension, which is 2 times M1 M2 over M1 plus M2 times G. You see that? So that becomes
Yeah.
the formula for tension. So these are the two formulas which you should remember. So what I've done here is I just summarize these two formulas. Formula one to give acceleration and formula two to give the tension. You see that? So once you have
Just
these formulas, substitute the values and figure it out.
right. But just a quick thing. So in the question that we tried to attempt in the beginning, you know how we use SUVAT to find the acceleration?
Yeah, yeah, yeah.
Can we find it with this formula straight away?
No,
I know one of the masses aren't given, but
that is why. That is why. One of the mass is not
um,
given, right? So we are given M2, but not M1. So in this equation, we have two variables, two unknowns. So how can you use this?
mm,
So we went to the Tuva
mm,
part, kinematics, to find
yeah.
what is A. Once we find A, you can now rearrange and find mass.
Oh, right. Okay. Okay.
That's what
Yeah,
it
yeah. So you have to use what's given in the question and then adapt with the formulas that you're going to use. You don't just go
is.
straight away and be like, this is acceleration. Okay.
That is
Yeah.
what it is. So what you were saying,
Right.
what we should do, we know exactly now what is the acceleration, right? So we calculated acceleration earlier, which was
Right.
3.2 meters per second square, right? You remember that part? So
Yeah.
in our question,
Yes.
in the formula which we derived, we substituted everything which was given to us, including the mass M2 of 3 kg. So I substituted 3 kg for
Oh.
mass M2, 3.2 for acceleration, and rearrange the equation, cross multiply, simplify, do all these steps, and then rearrange to find the mass, unknown mass M1. Do you see that?
Mm, yeah. I was doing question from a book, and yeah, I was like going round the around the circle for ages. I just didn't get it. But yeah, it's because I find values and then I completely ignore it when I go to the next step. I
Yeah.
have to still like think in my head that that's going to be used later on, which I never
Yeah.
do. I kind of block it out. So that's why. But yeah,
Perfect.
okay, I
So
got the
now you know
idea.
how
Yeah.
to put it. So put it the value, there's only one unknown here, mass M1, right? Use your method of solving. This is a neat method, cross
Okay.
multiply, simplify, take common things and then divide, and you find the mass as 5.9 kg. You see that? So now we know
Yeah.
masses, right? We know acceleration also. We can find the tension using our formula, 2m1
Mm,
divided by m1 plus n2. So we have this formula for tension, 2 times m1 m2 divided by the sum of the masses times the gravitational
mm,
force, right? And substituting the values which we just calculated and given to us, we can find the
mm.
tension, which comes to 39 newtons. Is that clear to you?
Yeah. Yeah, that's clear.
Perfect. No, I think,
Oh,
Amy, you've understood the whole process. To implement this system, I'll now like you to take a break, look for a question
Okay.
from your book, which was difficult for you earlier, and now you think you can do it.
Mhm.
So take your time to solve the question and then share with me your approach of solving that particular question. And in case you have difficulty, we can look into that also. Clear? So
All
we'll
right.
take a small
Yeah.
question. You take up a question, upload that question to me. I'll then share the solution and we'll discuss that now. Is that okay?
Okay. Yeah. Yeah.
Okay then. So now so uh, uh, So, Amy, thanks for doing the solution for the question, which you've done. Here is what I got from you, right? So, let me just share the question which you have sent. Okay. So, Amy, can you please read the question which you have sent and share with us the approach which you followed to solve this?
Yep. I can. So, two particles, P and Q, have masses km and 3m respectively, where k is less than 3.
Okay.
The particles are sorry.
Yeah, continue. The
Oh, okay.
particles are
The
connected.
particles are connected by a light inextensible string, which passes over a smooth light fixed pulley. The system is held at rest with the string taut, the hanging parts of the string vertical, and with P and Q at the same height above a horizontal plane, as
Mhm.
shown in the diagram. The system is released from rest.
Mhm.
After release, Q descends with an acceleration of a third g.
Correct. Part one.
Calculate the tension in the string
Mhm.
as Q descends.
Mhm.
Part B, show that K is 1.5.
Mhm.
Part C, state how you have used the information that the pulley is smooth.
Correct. Very important question. See, it talks about our approach also in a way, right? So, like part C tells you about the assumptions, right? And
Right.
part B of finding the mass of one of the masses not given to you, and C, tension. But in this case, simpler since they have already given you the acceleration of the whole system. Correct? Now, can you please
Hmm.
share? You have shared with me your solution also, I think, right? You sent. So
Yes. Yeah, I did.
what did you do? Okay. Now here is the solution which I received from you. Can you please explain me what did you do here? Yes.
Okay. So from the question,
Yeah.
I kind of, again, when we looked at the keywords, I
Mm.
kind of wrote them down.
Yeah.
So we said light inextensible, so I just kept that in mind, knowing the tension was the same
Yeah. Yeah.
throughout. And then it said smooth light fixed pulley, so the fact that it was smooth told me that there was no friction. So yeah, again, the tension was constant.
Yeah.
And then so when it came towards the end, it said the system is released from rest. So that's when I wrote u equals to 0,
Correct.
and I was trying to work with that. So when it said calculate the tension, I started off by using the tension formula
Mhm. That's
um,
very good.
to yeah, but then I kind of lost a little bit because you told me when you haven't got the constants, because I'm just given km and 3m,
Yes. Yes.
they're not actually numbers. So
Yeah.
I realized I couldn't work with that.
Correct.
Um, so I kind of put a question mark. But then you did obviously discuss how because we know that k is less than 3,
Yeah.
I know that 3m, the weight is heavier.
Yeah. Yeah.
So to
Okay.
find the tension, I did 3mg minus t, the tension, equals 3m, the mass, times acceleration, which was given in
Acceleration.
the
Correct. Correct.
question.
Right. So this is the
And
acceleration, right?
then,
So you know acceleration equals to one third of g. The
yeah.
correct. That is correct.
And then I just collected the like terms, moved the tension to the other side,
Mhm.
um, and then I got 2 mg, which
Perfect.
was the right answer.
That is true. That is true. Yes. So you directly cannot apply the formula because there are two unknowns, and this is how you rearrange and do a part
Yeah,
of the
yeah,
system. And this part you solve separately because the two are moving in opposite directions, right? So one block at a time you have to discuss. Can you discuss
right.
the solution of part B? Good approach.
Yeah, so thank you. So part B was about showing that K, which was the mass of P,
Mhm.
um, well, it's km, but showing that k is 1.5.
Yeah.
So when I started with this,
Mm.
oh yeah, so this was the issue kind of. So I did start, and then I because the k was less than 3, I thought it was moving upward, and
Mm.
so I made acceleration negative for some reason,
Mhm.
because going down was positive. But then I realized in the question with the pulleys that the acceleration is constant, because no, sorry, acceleration is the same in both sides of the pulley.
Correct.
So that then it meant that the acceleration still stays as a third g. So then I worked through it again, found like terms, mg and mg, they cancelled on both sides.
Yeah.
And where the arrow is, sorry, it's a little bit messy, but 2 minus k equals k over 3. And then I just moved k to the other side, got 2 equals 4 third k, and then k equals 1.5 using a calculator.
That is so correct. So you did finally found your
Yeah.
answer, right? So it is not that simple, right? You have to really think, and the way you're done in just
Mm.
a couple of minutes, that was amazing. I'm really impressed. So I hope this will give you a good start. I'd like you to continue with
Yeah.
the exercise, and if there is any difficulty, share your solutions, and from there we'll move forward, right?
All
Is
right.
so.
It sounds so good. Thank you so
That
much,
was
sir.
brilliant. That was brilliant. In such a short time, you did such a difficult question. It was a very tricky question, actually.
Yeah.
Right?
A
So,
lot of marks as well.
very good, very good. So, can you summarize today's learnings to end our lesson, please?
Yes. So we started off with the basics, which I definitely had to go back to, because, like Sir said, when you try and move forward, you kind of forget the previous points. So we talked about kinematics and how talking about the Suvat formula, and how it's all about that motion. And then we talked about Newton's laws and how that's more for dynamics, and discussing force and mass and acceleration, momentum, stuff like that. Then we moved forward and found we worked through a question basically step by step, constantly reading and understanding the assumptions that we make in maths. So like we discussed, light pulley, smooth fixed pulley, knowing that the tension's constant, things like that, because they appear a lot in the questions. And then after that, we worked by finding general formulas for acceleration and tension. And what I learned was with the pulley, there are like two systems, because the two objects that are on the pulley are moving in different directions, whereas the questions we previously discussed, they were moving in the same direction. That's why we could treat it as one system. So in this case, we cannot. So you have to like keep that in mind. And then I solved a question from my book, which I was quite impressed about. Just using, I realized there is a lot of trial and error, because I'm going straight into the formula and then realizing, oh, I haven't got all the constants. So then, but there are other ways around it, because you've showed me alternatives. So I worked through that.
So,
So
to
thank you,
solve such
sir.
questions, you have to see if acceleration or velocity or some things related are not given to you. First, use the
Yeah.
kinematic part, get those things in place. Then, use the dynamics part, treat each system individually, write down your equations separately. So, the mass, which is at the kind of n, which actually is moving in the direction which is shown, will actually give
Right.
you the acceleration, and the tension should be created from the other mass. So the other mass, as in the train
Yeah.
example, for the tension, we always looked into the last compartment. Do you see that? The
Right.
last box.
Right. Yeah.
Last box gives us the tension. So if you keep this
Tension.
in
Yeah.
all the system, so the one which is lagging most behind will go
Mm-hmm.
with the tension, because that is the tension which is making it move. Only force. Do you see?
Right.
No, that is
Only
the
force. Yeah.
yeah. So I mean, that will help you to understand from where to get what answer. You see that? So
Right.
right,
Yeah.
tackle the first equation, got the acceleration and tension from there itself, and then worked it out. So that was a good approach, and I think that should take
Yeah. Yeah.
way forward. So in the next class, share with me what all you do. Then tomorrow again,
Okay.
we'll take up another class on this topic to just
Oh, perfect.
give you more confidence. Okay, then. So we'll end it here.
Okay. Thank you so much, sir.
My
I
pleasure.
appreciate it.
Thank you.
Have a great rest of your weekend.
You too. Thank you.
Bye, sir.